use the graph of y equals the square root of x to graph y minus 2 equals negative square root of 3x plus 3. So this question is in explicit notation. There's no functions. There's no function notation. We're given the actual equation. This is one of the ones that we would recognize. Here are our first three key points, 1, 1, and 4, 2. We would know that. As far as on an exam or on a test, because this is one of the graphs that you know, this graph normally would not be given. You would be able to draw that on your own because it's one of the graphs you have memorized, and you have those three key points memorized right away. Same as we did in the last question, I'm going to rewrite the image graph with the y by itself. And I'm going to notice that the note that we wrote from yesterday, this is not in factored form. And you are going to be so tempted to move this 3 to the left, when in actuality, when I write it in factored form, it's only moving 1 to the left. So that special note that we wrote at the end of class yesterday, that says when you have a horizontal compression with a horizontal translation, you have to write it in factored form. And then I'm moving the 2 over, so there would be plus 2 at the end. Compared to my original graph, which is the square root of x, I have a bunch of new things. I have a negative, I have a 3, I have a plus 1, and I have a 2. Each of those things are going to be a transformation. We have to figure out what they're going to do. Which ones are inside the function, which ones are outside. Outside is going to be vertical. Can you see this negative is outside? It's going to be a vertical reflection. You're going to multiply your y values by -1. The 3 is inside the square root, would be inside the function. That will be a horizontal compression. You're going to multiply your x values by 1/3. The plus 1 is inside the function, a horizontal translation, 1 to the left. And the 2 is outside the function, a vertical translation, 2 up. Now, if I choose the 3 points that I have, I might run into a bunch of fractions. For sure, you always have to include 0, 0. But in choosing your other points, you do have some options. And in this case, can you see that with the x by 1/3, that I might want to pick 9, 3, just because my numbers work out nice. That's not normally one of my 3 points on my square root graph, but we can extend it. So what I'm going to do in this one, I'm still going to use 1, 1 to show you that if you pick something with fractions, it's not wrong. But I'm also going to choose my third point to be 9, 3 to show you why choosing good points is sometimes nice. Draw my arrows. We have stretches, compressions, and translations. Above my first set of arrows, I put all of my stretches, compressions, reflections. So above here, I'm going to write x by 1/3 and also y by -1. Above my second set of arrows is all my translations, so I'm going to go 1 to the left and 2 up. I like to deal with my x coordinates first, so I like to try to write x first. Sort of, again, an easy place to make mental math mistakes is you don't know how often students multiply the x coordinates by -1 instead of the y coordinates by -1. Just takes a moment not to think, and you start doing something in the wrong way. So here, I want to multiply my x coordinates by 1/3. This will still stay 0. This one is 1/3, and this one is 3. So we can see that by choosing that last point, my x value is still a nice whole number. Whereas with the 1, I end up with a fraction. Not wrong, just makes our mental math a little bit more difficult. Multiplying y by -1, this would be 0, -1, and -3. Now we need to move 1 to the left. So this is easy to move 1 to the left. This is a little bit trickier. Again, working with fractions. What's 1/3 minus 1? Maybe some of you can do that easily, mental math in your head. Maybe some of you need to review your fraction rules and actually do your rules. 1/3 minus 1. How do I subtract fractions? I would need a common denominator. So I need to change the 1 to be 3/3. Then instead of 1/3 minus 1, I could say 1/3 minus 3/3. How do you subtract fractions? Subtract the tops. So 1 minus 3 will give me -2. And it becomes -2/3. And then 3 minus 1, oh, that's a lot easier. It'll just be 2. Finally, we need to go 2 up. So 0 will go to 2, -1 will go to 1, and -3 will go to -1. And we've got our 3 points. So over here, I'm going to label these points. So -1, comma 2. -2/3, comma 1. I'm just going to put that dot approximately where -2/3 is. And then 2, -1. Now, when connecting those dots, it's important to know where's your starting point. Well, 0, 0 is our starting point here. So that means -1, 2 is my starting point here. I need the curve to look like this. Why? I had a vertical reflection. Can you imagine this original graph getting flipped down vertically? Then that curve has to match that. So there's our final graph. This question, rereading it, it wants the domain and range of the blue graph only. So the domain, do I have a smallest x value? Yes. -1, and all of my x values are bigger than or equal to -1. I don't have a smallest y value, but I do have a biggest y value. The biggest y value is 2, so I can write that y has to be less than or equal to 2. Circle questions 8 and 10.